Welcome everybody. So probably you know about some risks in distributed programming, and hopefully you're eager to hear about some possibilities MicroProfile Fault Tolerance will give you to fight against these risks. So what I will do today is the talk is consists of 3 parts. The first is kind of academic lecture about fallacies of distributed computing. The second is an introduction to fault tolerance. So it's on a beginner level. If you already know fault tolerance, probably you will not learn anything new here. And the third part is some code. We will look at code, we will run code, and hopefully you will learn something about fault tolerance by running the examples. Who am I? So in fact I was born not far away from here in Metzingen, and I studied computer science at the University of Stuttgart. Now I'm a professor of computer science at the Hochschule Braunschweig-Wolfenbüttel. It's a Fachhochschule in Germany. So I'm working in the enterprise Java environment, so I wrote some books about JSF, JPA, Hibernate, and eventually the older one will remember JBoss-Theme. Does anyone remember JBoss-Theme? Oh, almost as old as myself. Okay, and I'm also a Java user group co-organizer in Braunschweig. Okay, fallacies of distributed computing. Probably the older one will also know there was some years ago, there was Sun Microsystems, nice company, not inventing, but one of the companies doing much with Unix workstations. So the mic is muted, or you yeah, okay. The Sun guys coined the slogan, "The net is the computer." Eventually you will remember. So they know about the risk of distributed programming. And there was a Sun fellow, Peter Deutsch, 30 years ago. He coined 7 fallacies of distributed programming. And James Gosling, father of Java, added an 8th one in 3 years later. So I will go through the fallacies and discuss very small discussion how technical things like fault tolerance will help us, or there is no chance because it's human-based and no technical framework will help us by some fallacies. So the network is reliable. So of course you know it's not reliable. So for example, if you look at switches, they have some mean time between failure, really big numbers, many hours, but from time to time they will fail. They can also be power failures or human mistakes. So there was a AWS outage 2 years ago or so, and it was caused by humans. So we will see that fault tolerance can help us with unreliable networks. So second fallacy is latency is 0. You all know it is not. If you type some into your URL, in the URL line in your browser and type return, so sometimes it happens nothing, so you have to retry. And retry, we will see later, is directly annotation by fault tolerance. So you can tell your program, please, if something failed, retry and retry and retry. So bandwidth is infinite. So it's becoming better and better, but of course it's not infinite. So the network is secure, so we have to differentiate between 2 kinds of security. So and the first is there are many bad guys out there try to hack your systems. So there is no chance on a MicroProfile or fault tolerance level to do something against it. But there are also more technical security risks, and there are denial of service attacks. And fault tolerance is not really good at fight against denial of service attacks, but we will see there is something which can help a little bit. Okay, so fifth fallacy is topology doesn't change, so it's changing constantly. So all providers will rearrange their lines, and you can take for sure that the network topology changes, but there is no help from fault tolerance because we will not see that the topology is changing. So this fallacy is removed. So there is one administrator. So there is some contact form at AWS, so if something went wrong, you can submit a form, but you're not sure will it be read in a minute or an hour or in some other time. So fault tolerance will not help us with this policy. Transport cost is zero, so we have to differentiate between two point of views. There is a technical point of view, and of course we have to marshal Java to JSON and unmarshal JSON to Java, and transport costs are of course not zero. There's an economical point of view to transport costs, so you have to pay your cloud bill. But also here, no help from fault tolerance. So the network is homogeneous. It is not. So probably, I guess, I don't know it, probably most of the hosts are based on some Unix or Linux. But so, for example, if you're German, sometimes you will get mails where some German umlauts are not rendered correctly. So the network is not homogeneous in reality. So at the end, there are 4 fallacies, and we will see in some minutes that fault tolerance can help us a little bit in fighting against the risks behind these fallacies. Okay, so jump into fault tolerance. What is fault tolerance? It's about 5 annotations, and these annotations are interceptors, and the annotation is bind to an interceptor. So I hope you will know the concept of interceptors. It's the same CDI interceptors. It's the same as it was with enterprise Java beans 20 years ago. And so it's simple, a matter of fact that these are simply annotations bound to interceptors. So a warm welcome to Emily. So as we will look, eventually we will look at the Java doc of fault tolerance, and she's the author of all the Java doc files. You will read her name. Okay, so fault tolerance is implemented by almost all implementations at the market, without Spring, of course, but you can use Wildfly, OpenLiberty, Pajara, Tommy, Quarkus. I will use Wildfly with my examples. So fault tolerance is included in MicroProfile, and the latest version of MicroProfile is 6.0, and fault tolerance is the version number is 4.0 included in MicroProfile 6.0. And there are handful of annotations: fallback, retry, circuit breaker, timeout, bulkhead. The last one is asynchronous, not a really fault tolerance annotation in the sense of fight against some risks of distributed programming, but we will see. Okay, so the annotations, I will go through the annotations to give you a feeling, and in the third part I will run some small examples, so hopefully you will get much more feeling about what about these annotations are. So, okay, timeout, as the name suggests, if the guarded method takes too long, you get a timeout exception. So nothing very special in it. There, you can define how long are you willing to wait. So you can specify how long the wait time is, timeout time is. Retry. So you remember the example with your browser. So you can press F5 and this is exactly the same. You can say your application, if a method invocation fails with an exception, please retry, please retry, please retry. So there are some parameters to configure it. So I have to switch the slides so I can mark it. So there are two possibilities to define how much retries you are willing to do. The one is on the number of retries, and the second is on the duration you are willing to wait. There is also the possibility to list all the exception types where the retry should happen or where the retry should not happen. And you are also allowed to define some delay. So it is not the case that if some exception is thrown, a retry will immediately retry it, but you can say, please wait 1000 milliseconds. And you can also do some random jitter of the wait time. So you can say 1000 milliseconds, but eventually more or less. Fallback. Fallback annotation simply defines an alternative execution path if the latest call failed. You can define via the value attribute the class, the type of the alternative method. So this is based on some interface with a handle method. So this is the way you can use the Java type system. There is also an alternative where you can specify a method in the same class, but this method via fallback method attribute is defined by a string. So if you have a typo in it, so you're lost. So you're of course invited to take some photos, but at the end I will show you a GitHub repo and you can download all the examples and also of course the slides. So apply on and skip on, as we already saw in some later annotation, you can define the exception types which you want to do the alternative execution path or not. Okay, so bulkhead. So you remember the denial of service attack. So the bulkhead annotation limits the number of concurrent calls to prevent faults to cascade into another part of the system. So there are two alternatives with bulkhead. The first one is called thread pool. So if the annotated method is also annotated with @asynchronous, this is called thread pool isolation. And in this case, you can define the number of concurrent requests and the size of the waiting queue. So if the method is not asynchronous, this type of bulkhead is called semaphore isolation, and there you can only define the number of concurrent requests. I will show you later on examples of this. Last one is circuit breaker. So there is a book about from Michael Nygaard. Release It. It's called Release It. The book is called Release It. And some years later, Martin Fowler wrote a blog post. So if text is colored like Martin Fowler here, it's a link into the net. But if you Google about a circuit breaker and Martin Fowler, you will be immediately at this blog post. So circuit breaker means prevent further damage by not executing functionality that is doomed to fail. So the concept is fail fast. If there is a great possibility that something will go wrong, let it fail as early as possible. So the circuit breaker is like electric circuits. Can have three states: closed, open, and half open. So closed is everything is fine, and the calls will go through the circuit. So if you have too many, so I will go not through all the parameters, but if you have too many exceptions in the past calls, so you can define please open the circuit. And then the next call will fail fast and get an exception and return. So you can stop doing more waiting time or damage to the rest of the system. So if the circuit opens and you wait a little bit, eventually everything will fine again. So the circuit will be in a state half open. And then in a half open state, if there are calls, some of the calls will go through the callee. And if it's still it will cause an exception, the circuit reopens. But if there are some successful calls of the callee, the circuit will close. And there are many attributes you can fine-tune the circuit breaker. I will also have an example for this. So the last annotation is asynchronous, and it simply states that run it in another thread. So it's running asynchronous. So it's almost the same as in EJBs or Jakarta Enterprise Bees and Jakarta Concurrency. So you have three asynchronous annotations if you are using Jakarta EE and MicroProfile together. So three alternatives. Okay, so before I start the demo, some remarks. So the annotations can be used on the class level, on the class level, but also on the method level. And if you define it on the class level, it belongs to all the public methods. If you use it on the method level, it's only for this one method. Okay, there is also a defined sequence if you're using annotations in common. And I don't remember the version number of CDI. In former times or in version 1.0 of CDI, you have to define the interceptor sequence by entries in the BeanXML deployment descriptor. And in some version there was added a priority, so you can add a priority for your annotations to define the sequence in which the annotations are called. Okay, and another point, annotation parameters. So the attributes of all these annotations on the slides can be configured via MicroProfile config. So there are two point of views to this. So if you remember also the older one, so one reason to introduce annotations into Java was that in former times you have your Java code and you have your XML deployment descriptors. And to understand what's going on, you have to look at both. So the idea of annotations was the meta information coded in XML should be included in the Java source code. So this is the idea of annotations. Meta information inside the source code, not outside. So from this point of view, the possibility to do some fault tolerance configuration via MicroProfile config is bad. But if you're in the cloud and inside containers, though the standard way to get some configuration inside the container is, for example, using environment variables. And therefore you have, of course, use MicroProfile config to get the parameter you add to the container from the container inside your application. So this is, of course, it makes sense if you're using some container infrastructure. Okay, so I'm at the end of my slides and I will switch to IDE and I will show you some examples. Okay, so the first example is simply to demonstrate that in almost all my examples I will annotate a REST endpoint, like here. So this is a REST endpoint. Though the first example is that the annotations you're using, you can use it at an endpoint, but you can use it on every Java method, because endpoints are also conventional Java methods. They are called by the URI to method dispatcher of the REST implementation. So nothing special. But there is an endpoint search demo, and what I does is there is a method getSearchResult from DuckDuckGo, which is simply a class. And so the default is I'm asking DuckDuckGo, and I code it in the result only the length, not the text, but the length of this one. And there is a timeout, and there is a fallback, and the fallback is please ask Google for the same question, and the return code is like that. Okay, so if you download the code from GitHub, you will have a guided endpoint with all the examples I will go through in the next minutes. So search demo is here. So so this is HTTP. I don't know if you know it. So it's from my point of view, it's a better alternative to wget or curl. So it's much nicer to use. So it's included in Fedora. I'm using it, but it's also available in Windows. So this is DuckDuckGo, and depending on the Wi-Fi here, I can shorten the timeout value, and I will retry, and then it's from Google. So because I was not able to get it from DuckDuckGo in 1 second, 1000 milliseconds. So if I increase it, it's from DuckDuckGo again. So it's very easy. So and you're invited to download all the examples and use it as you want and play around with it. Okay, so the next one is timeout with fallback. So this is inside there, and here it's also the case that the method which is called is allowed to sleep some time, which is simply thread sleep, in fact. But what I did is I can increase the sleep time with another endpoint. This one is get, this one is post, and so I can so this is the next example. So it's a sleep time example. So I can ask for the sleep time, and the sleep time is 0 milliseconds. And when I increase it to a wait time of 2 seconds, 2000 milliseconds, and I repeat the timeout with fallback, it is not handled with this one, but with the fallback method. So the first example was, the fallback class. The first example was via our fallback method, and now we are at the fallback class. So this is simply a class implementing a fallback handler interface, and you have you have to implement a handle method. So it's easy like that. So I have to check what's next. So this is the retry, fault tolerance retry. So this is timeout, this is a retry. Okay, so the retry is, please, if something goes wrong, retry the first time, retry the second time, retry the third time, and but don't retry it a fourth time. So I can run this endpoint, and it's from retry. But here it's the same. I can increase the error count, and I can say I want to set the error counter to 3, and after that we can say here it's called really 3 times. So we are in fact in the possibility to retry without doing any programming. And if I increase the error counter to 6 and do the retry, we'll see that after the third retry there is an exception thrown, and the example returns what was written down in the exception here. So simply by annotating a method with retry, and it doesn't matter if it's a REST endpoint or some other normal method, you can, it will be retried for you, so you don't have to program anything. Okay, so examples for bulkhead and circuit breaker are kind of not so easy. So what I did here is there is an endpoint with thread pool isolation, and you don't see anything if it's called only one time, because to see bulkhead in action you have to call it more than one time, of course. And so there is a program called Apache Bench. Eventually you know it. So this I will increase the font size a little bit. So this Apache Bench was done by Apache guys to benchmark their HTTPD container, so the normal Apache web server. So, but you can of course use it with every HTTP endpoints. Okay, and what I'm doing here is the first parameter minus v is verbose, so you can define some level of verbosity. And the next is use 10 calls, so repeat 10 times the HTTP request and do it with a concurrency of 10. So, and if you look at this, so scroll down, I will not look into the details, but at the end you will see everything is fine. But if you increase the number, you will see that there are some calls which are which fail fast. So they don't get into the backend, but they the bulkhead annotation is responsible for return it to the sender without calling something behind. Okay, so the next one is, and I will skip the semaphore thing. This was a thread pool, but semaphore is exactly the same, but not with asynchronous method because of time constraints. So the last one is fail fast. And fail fast is also, of course, not so easy to do something with really some meaning inside it. So what I do is I simply return a method, this one, and so if everything is fine and you have a small amount of errors, you can call it. And from time to time, the method returns correctly, one more time, but from time to time, 30% of the cases, there will be an exception. So something went wrong. But this doesn't matter because the circuit will be closed, because I'm a very old man and my requests are very slow in sequence, so nothing special about that. But if you, where is it? If you say, please have a very big percentage of failures, it's still the same. If I as a human only request some seconds delay, there will nothing bad happen. But if I do it very fast, I will get in this example the message that the circuit breaker opens. And so if you remember my introduction, so if I wait now some time, the circuit breaker will go into half open, and when I retry it, there was an exception, but it was half open, so it was it goes through to the method behind it. And because I waited too long, it's succeeded one more time. So if I do it with a smaller delay, so it really opens. So now it's half close, and if I wait long enough, it will be closed. So I will return. So the demo is, sorry, that one. The demo is at the end, and I will skip the slides, because eventually you will try the examples, and you are invited to do so. Please download the slides and the code, and you can use it for your own. So you're invited to do so. Okay, I'm out of time, but maybe one question? Yes. Because of the video, you have to repeat.
Thank you for the great talk. With the thread pool, I think in your example, it went to an exception, so it failed. Was that correct?
Failing always means exception in Java, right?
Is there also an option to have it in the queue to block?
I don't understand the question, sorry.
I think it was with the bulkhead.
So it's the fail fast. So a failure always is throw an exception in Java. Always. So two mics there.
So it's Bernd demonstrates basically is each individual annotations. The other thing is you can use annotations together. You can do basically a bulkhead together with some other circuit breaker, and based on your circumstances.
You can combine, of course. Yeah. Okay. So I'm out of time. Thank you for coming, for being here. Thank you very much.